Thank you for watching this video. So on this video we do of November 2023 question paper mathematics number 2. These are trigonometric functions, as you can see here. No problem. So they are asking you, let me read the statement. So in the diagram below, the graphs of f and g are drawn from x is equal to 0 to 180 degrees. A is a point that lies on f. Let me read this again. In the diagram, the graph of f and g are drawn for the interval x is from 0 to 180 degrees. And you are told that A is a point that lies on f. No problem. So we have two functions. Here is f, which have this equation here, 2 sine 2x, and g, this green one here, which have the equation of negative g of x equal to negative cos x plus 45. Right? So these graphs are drawn from x equal to 0 to x equal to 180 degrees. So they are drawn on this interval here. No problem. So you are told that A, which has the coordinates of 105 and minus 1, is a point that lies on G. So here it lies on F. Here is it on the blue functions, lies on F. No problem. So let's go. 6.1. Write down the period of F. So the period of F. What is the period of F? I'll say the period is the time your function takes for one full oscillation, right? So if you look from here, go up, go down, you return to exactly where you started, right? So this blue function is full here. So after this, it will be repeating the same pattern that you already see here. So to move from here up, down to that point, it's 180 degrees. So that's the time it takes for one complete oscillation. So the period of this function, of this blue function, is 180 degrees. So because, as you can see, it starts here at 0 and goes there. So if you can extend it again, you will see that you are duplicating this part here already. So one full oscillation of this graph is 180 degrees, right? But if you can't look at it that way, you can say, okay, the period this is a what? Of sine kx, right, is equal to 360 degrees over k. You also know that the period of cos kx is equal to 360 degrees over k. You know that the period of tan kx, right, is equal to 180 degrees divided by k, depending what is the function that you are given. So you are given, you know that your f of x is equal to 2 sine 2x, right? So, and you said, so now the period of sine, of 2 sine 2x will be equal to what? 360 degrees divided by this. Because I said for sine kx, it would be sine for the period of sine kx, you divide 360 by the value of k, right? Which is the coefficient of this x here. The coefficient of x is 2, so you divide by 2. So your period becomes 180 degrees. That's how you calculate the period. And we also use similar formulas to find the period for cos, sine, and tangent. Done. We move. They want you to find the range of G on the interval x. Okay. So they want you to find the range of G of x, which is equal to what? Negative cos x plus 45, right? Range of this function. You know the range is the set of y values that your function is using. So this function, g, is this green function here. You know that the maximum value of this function is 1, right? The maximum value of this function is 1. And the minimum value of it is this value here. What is that value? So the value there, because you want to arrange the set of y values that the function is using. So this function uses all the values from -1 up to all these values that are here. From here up to 1. Those are the y values that the function is using. But now you need to find what this value is. You know that x is equal to 0 there. So you know that it's 0 and y, whatever the y is. So to find that, you say, okay, g at 0 is equal to negative cos 0 plus 45. So g at 0 is equal to -1 over root 2. So the coordinates of this point is 0 and -1 over root 2, right? So the y values that the function is using are from -1 over root 2 to 1. So your range is y is an element of what? Of -1 over root 2 to 1, which is the maximum. This is your range. Or 1 would write as y is less or equal to 1, greater or equal to -1 over root 2. This is your range. Same thing. Done. We'll move to 6.3.1. No problem. What are they saying at 6.3? They are saying 6.3 read as follows. Determine the values of x in the interval from 0 to 180 for which f of x times g of x is positive. So they want the values of x where your f of x times your g of x is positive, where the product of f and g is positive, right? How will you find this? You will find this when you multiply, when g of x, you'll get this product when g of x is less than 0 and f of x is less than 0. So by this I mean that if g of x is negative and f of x is negative, and you take the product of both of them, right? Their product will be positive, because a negative times a negative is a positive. So you will find this condition where both your functions are less than 0, or you will find this condition where both of your functions, g of x is positive and f of x is positive. So you must look at your graph where both of them are positive or both of them are negative. That's when you obtain this condition of having a positive product. That's what we need to do. So let's go and look at our graph. So you can see here, if we start at 0, look at this point, you can see 1 is negative, 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 right? 1 is positive, 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 right? And then the other one is 0 here, the other one is positive there, right? If you look after this, here is positive, 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 because it's above the x-axis, so it's positive. And you look at your green one, you can see it's also positive, also positive, also positive, also positive, also positive, also positive, and then it becomes 0 here at this point. So the product of these two functions is positive 1. It's positive from this point, after this point and before that one. So it's positive on this interval here, because between 45 and 90 degrees, both of our functions are positive. And at 45 it's 0, so you can't include 0, because 0 times that, your answer would be 0, but you want your product to be above 0. Even 90 degrees, even 90, you won't include 90. Why? Because at x is equal to 90, your g is 0. So if you multiply this 0 and that point which will be above here, it will be 0. And you don't want your product to be 0. You want your product to be above 0. So these x value between 90 and 45 are the ones that will give you a product of your function being positive, because that's where both of them are positive. Because you only see this condition. You don't have this condition where both of them are negative. So the product of both function f and g is only positive, right, when both f and g are above 0, which is these positions here, from this position between 45 and 90 degrees. So how do you write that? You say your x is between 45 degrees and 90 degrees. Or one will say x is less than 90, greater than 45 degrees. So we don't include the 45 because the 45 is 0. So 0 times that is 0. We want it to be above 0. And we don't include 90 because 90 times that, or 0 times, because at 90 g is 0. 0 times that g of x should be 0, and we don't want it to be 0, we want it to be above 0. Done. We're done with this one. Then we move to 6.3.2. What are they saying? For which values of x is f of x plus 1 less or equal to 0? They are asking for which values of x is f of x plus 1 less or equal to 0? No problem. Which one is f of x? F of x is the blue function, which is this function here. So, if you look at this, you can say, okay, you can simplify and say f of x, you want the values of f, where f of x is less or equal to minus 1. Right? Which one is f of x is the blue one. So if you draw f of x, here is it? Fine. It's minus 1 and below. So you want the values of x, right, where your function is minus 1 and below. So your function is minus 1 along this line here, because this function, this line, is y is equal to minus 1. Then you can see that from here, it is minus 1 and it's below minus 1 here, up until it returns back to 1. So you must find what this value is and what this value is. You know what this one is, 105. You know this one is 135, right? And this one is equal to that one, right? So it's more like you have the x coordinate, you have a midpoint, you want that x coordinate that is there. So what do? You say x coordinate of a midpoint is equal to x1 plus x2 divided by 2. Right? No problem. What is the x coordinate of the midpoint? It's 135 plus is equal to x1, which is what we're looking for, which is this guy here, plus x2, which is 105, 1 over 2, right? What do? So 2 times 135 is equal to x plus 105. No problem. So what is 2 times 125? That is like 270, right? So 270 is equal to x plus 105. So x1 is equal to 270 minus 105, which looks like x is equal to 270. So it looks like 160. So 165. Looks like your x value here is 165 here. So our function will be below, will be minus 1 or below, from x equal to 1 for x is from 105 to 165. So this condition will be satisfied if your x is from 105 to 165. One will say x less or equal to 165, but greater or equal to 105. Done. Done. So now we move on to 6.4. What are they saying in 6.4? They're saying another graph P is defined. So you have another function P of x defined as minus f of x, right? It's a negative. It's a negative of f, which is this one here. No problem. So another function P is defined as P of x is equal to negative f of x. They're saying D lies on P, right? Determine the values of k, which is the x coordinate of D, in the interval from 0 to 180 degrees. So you're given a function defined by this. So P of x is equal to negative 2 sine 2x, right? And you're told that this function, this is the coordinate. This point lies on your function P. This point D lies on the function P. No problem. So let me read this again. 6.4. Another graph P is defined as P of x is equal to negative f of x. No problem. They are saying D is a point D which has the coordinates k and minus 1, lies on P, which is the point on P. Determine the values of k in the interval from x is from 0 to 180 degrees. They want the possible values of k. How do we do this? We say, okay, we have the coordinates of D to be that, right? K and minus 1. So, which means if we substitute k here in the point of x here, our answer will be minus 1. So, which means we have minus 2 sine 2k is equal to minus 1. Then divide by minus 2, divide by minus 2. So, sine 2k is equal to 1 over 2. So, your reference angle is equal to 30 degrees, right? So, what do we do from here? So, okay, now my 2k is equal to so my 2k or your 2k is equal to 30 degrees or which implies that your k is possibly 15, or you say your 2k is equal to what? Is equal to 180 minus 30, which is equal to 150 divided by 2 divided by 2. So your k is possibly 75 degrees. So these are the possible values of k on the interval from 0 to 180 degrees, 15 degrees, 15 degrees and 75 degrees. Done. We have one more question. So I'm going to clean this part and then we'll do that one more question. So now we're doing the last question, 6.5. That's saying graph H is obtained when G is translated 45 degrees to the left. Determine the equation of H and write your answer in the simplest form. So they're saying G of x, which is equal to negative cos x plus 45, right? Is used to form our function h, right? What did we do? G is translated, it has been shifted 45 units to the left. That's what they're telling us. They're telling us that it is translated 45 units to the left. What does that mean? If G of x is this thing here, it means that your x plus 45 is equal to minus 45, which is, it has been translated 45. So this had been translated 45 units to the left, right? So which means that you have this equation of x plus 90 is equal to 0. So your new function will be h of x, which will be equal to negative cos 90 plus x, which is the same as ask yourself, where is 90 plus? It's on the second quadrant. What sign is your function there? It's negative, so you have a negative of what? So you have this negative, which is this negative sine x. So this becomes sine x. So your new function h of x is equal to sine x. Because you say, okay, my function g is translated to form h, right? And g is translated to 45 units left. So which means this is equal to minus 45. And then transpose the 45 becomes x plus 90. Then you take this back to where it's coming from. And you have negative cos into 90 plus x, right? And then you ask yourself, so this negative is this one. Then you ask yourself, where is 90 plus? So on the second quadrant, what sign is your function? It is negative. And then because the maximum is 90 degrees, it will change to its maximum, to its co-function identity, which is sine. So you have negative sine x, which eventually becomes sine x. So your new function, h of x, is equal to just a sine function of x, which I like calling it the natural sine. So I think we're done here. Thank you for watching. Now we'll move to question 7.